Okay. Hi, Assalamualaikum. So today we continue discussion tutorial session set 1 paper 1. This is trial SPM 2021. So number 1, which of the following is a base quantity? Okay, so you must remember there are 7 base quantities with its physical units or SI unit. Okay, base quantity is quantity that cannot be defined in terms of other physical quantities. Dia tak boleh combine dengan physical quantities yang lain melalui formula. Okay, for example here we have weight, so this is not base quantity. Volume, also not a base quantity. Heat, also no. Then we have D, luminous intensity. Yeah, the SI unit that we use for this one is candela. Luminous intensity. Okay, number 2, which graph shows P is inversely proportional to Q? If you write the relationship, it should become like this. Inversely proportional to Q. If you read directly proportional means P directly proportional to 1 over Q. So if you have the graph P against Q, means the graph must be a curved graph C. So this is inversely proportional graph. If you plot P against 1 over Q, you will get directly proportional. Okay, number 3. Every object remains in a state of rest or uniform motion in a straight line unless it is forced to change. Means external force act. That state by an external force applied to it. The statement is explained by. If you look at here, remain state of rest, okay, or motion. So this is something about concept of what? Inertia. This is the concept of inertia. So the related law to the inertia is Newton's first law of motion, or also known as law of inertia. Okay, so answer is A. Yeah? Okay, number 4. Diagram 1 shows a rifle. A bullet is fired at velocity 150 meters per second. What is the recoil velocity? So this is the recoil velocity. Yeah? This is the velocity of the bullet. Okay, you can put as V1, here is V2. So you want to determine what is V2. V1 is 150 meter per second. Okay. Initially, this rifle and the bullet are at rest. Means total momentum before the bullet is fired equals to 0. Okay. Based on principle of conservation of momentum, total momentum before the bullet is fired is equals to total momentum after the bullet is fired. That's why we call it conserved. Right? Total momentum remains equals to 0. So from here we can write the formula for this one. So this is a case of explosion. Means momentum of the bullet forward will produce momentum of the rifle backward. Okay, so we can write something like this. M1 V1 equals to M2 V2. Okay, for M1 is the bullet, unit must be kilogram. V1 150, M2 is 2 kilogram. We want to find V2. Thus you get V2 equals to 1.5 meter second to the power negative 5. Okay, the answer is Y. Okay, so you must understand the principle of conservation of momentum. So recoil velocity is opposite direction to the direction of bullet. Okay, number 5, a goalkeeper catches a ball. The impulsive force can be reduced if formula. If you got the formula, go and check in the list. M B minus U divided by T. So you want to reduce F, you must reduce what? You can reduce the change in momentum, and then you can lengthen the time of the time taken, because relationship here is inversely proportional. Okay, let's look at A. The goalkeeper moved forward before stopping the ball. The goalkeeper want to catch the ball. So you move forward, it will increase the impulsive force. Okay, the goalkeeper must move backward so that it will lengthen the time taken. Okay, so this one is not the answer. The goalkeeper moves slightly backwards before stopping. Yes. The goalkeeper stood upright and letting the ball be stopped at his body. No. The goalkeeper stood up straight, then jumped up and let the ball rest on his body. Also cannot. Okay, so the best answer is B boy. Okay, move backward a bit. Same thing, if you want to catch the ball using your hand, you need to move your hand a bit backward before you catch the ball. You cannot run forward and try to catch the ball. Because that one will cause a larger force act on your hand. Okay. Number 6. Wait, it's hanging. Okay, number 6. Diagram 2 shows a stone and a piece of feather were dropped simultaneously from the same height. What happens to the fall time for both objects? So here no mention about um, vacuum or air resistant negligible. So in this case, there is air resistant. So when you try to mark the force, of course, there will be W, the gravitational force weight, and also there is air resistance. Okay? The factor that affects air resistance is area of contact. As you can see, for the stone and the feather will have larger surface area of contact. Thus, air resistance that acts on the feather is larger than the stone. Okay, so you can see there is a air resistance and the weight of the feather. So if the air resistance is large for the feather, it will cause net force to become smaller. So when net force becomes smaller, acceleration may become smaller. So means the feather will fall down slower compared to the stone. Same case for the stone, smaller air resistance. This one will cause larger net force, thus acceleration is higher. So the stone will move down or fall down faster compared to the feather. Okay, so the best answer is B. The stone falls faster. Number 7, diagram 3 shows three identical satellites PQR, which are located at different height from the Earth's surface. You can see the height given. Which one shows the correct comparison? We want to compare the gravitational force and acceleration due to gravity. Okay. Gravitational force, as we discussed, G m1 m2 divided by r squared. Here given identical satellite. Identical means same mass. So means we avoid this factor because it becomes constant. The relationship is 1 F is directly proportional to 1 over r squared, or F inversely proportional to r squared. For the case of P, Q and R, so you can see the distance between Q and Earth is smaller. Thus, FQ is the largest one, followed by P, followed by R. Okay, so means Q larger than P larger than R. Okay, we get the first one here. Second one, the gravitational acceleration. So from the formula mg equals to g because here is Earth. Okay, so this is mass of Earth divided by r squared. So we can cancel the mass of the satellite. So we get small g, g m divided by r squared. So this one is constant. The value of g also inversely proportional to r squared. Thus, gq more than gp more than g. Okay, so which one is the best answer? For number 7. Okay, Q more than P more than R. Yeah, Q more than P more than R. Same thing for G, Q more than P more than R. So the answer will be okay. If any question, you can write in the chat. Okay, number 8. Diagram 4 shows the area covered at the same time in the region PQR and XYZ of a planet rotating around the Sun. So this one, I hope you still remember the Kepler's second law. Okay, area must be equal for the same time interval. Okay, mean area covered by PR and area covered by XZ, okay, are equal because here mentioned same time. Okay, which of the following is true about area PQR and XYZ? So you just apply Kepler's second law. So it will spit out same area or the same time taken. Okay. Number 9, mass 0.2 kilogram, spin horizontally, circle 0.5 meter radius. Okay. Constant speed for calculate centripetal force. Okay. Formula F equals to mv squared over r. So you just substitute the value of mass 0.2, and then the velocity or the speed for r radius 0.5. Okay, so we'll get the answer for number 9, 6.40. Okay, number 10. A gas in a sealed container, pressure, temperature. Determine temperature if the pressure increased. Okay, so this one just mentioned about pressure and temperature. No mention about volume. Okay, there is a magic triangle, PBT. Belajar cepat pandai. Okay, Boyce, Charles, and pressure, or Gay-Lussac law. GL, Gay-Lussac law. Okay, so if mentioned about pressure and temperature, means volume is constant. Okay, so the relationship between P and B inversely proportional. Sorry. Yeah. Mention about temperature. Yeah. Volume constant. So this is Gay-Lussac law. For Gay-Lussac law, you have P directly proportional to absolute temperature. The temperature is a temperature that's stated in Kelvin scale. So we call it absolute temperature. So we get the relationship as we get is P1 over T1 equals to P2 over T2. Okay, so what you do, you just substitute P1 125 over temperature must convert to Kelvin, 30 plus 273. So 303 Kelvin. And then T2 you want to find. 201 T2. Okay, so you calculate for T2, you will get the answer. Okay, so you will get T2 equals to 487.2 Kelvin. So answer given in Celsius, what you do, you need to minus 273. Okay, you will get 214. I round off 214 degrees Celsius. So answer is B. So be careful for gas law. For gas law, if you discuss about Charles law, and also Gay-Lussac law, temperature in Kelvin. Mesti tukar Kelvin. Macam mana tukar? You kena plus 273. Kalau you nak tukar balik, you dapat Kelvin, you nak tukar balik ke degree Celsius, you minus balik 273. Okay. So be careful. Some students, they get 487 straight away, tick the C. So it's wrong already. You better be careful with the unit. Okay. In calculation, you always get Kelvin. Okay, because the gas law only valid at absolute temperature, temperature in Kelvin, not degree Celsius. Okay. Okay, number 11. The patient's body temperature can be determined by a doctor when thermal equilibrium occurs. What is the meaning of thermal equilibrium? So just definition. Okay, thermal equilibrium can be stated the net rate flow between two objects is zero. Yes, correct. So this answer is correct. Straight away we get. Number 12. Diagram 6 shows 4 blocks VQRS, different specific heat capacity but same mass and initial temperature, were heated on the stove by same amount of heat energy. Okay, so all constant, only the value of C. So from the formula, Q equals to MC theta. Let's say heat supplied by heater. Okay, PT equals to MC theta. So the value of C is equals to PT divided by M theta, where theta is equals to final temperature minus initial temperature, the difference between final and initial. Okay. So here the power supply, the mass all same. So means the relationship between C and change in temperature. Initial temperature also same. Okay, theta 1 also constant, same initial temperature. So means C 1 theta 2. Okay, so now we want to answer the question. Okay, given PQR, from here we can see CP is more than CQ, more than CR, more than CS. Okay, specific heat capacity. So the relationship between, just now we already show that C theta 2, the final temperature. So which one has the highest increase in temperature? So I will relate to here. So means theta for P is less than theta Q less than theta R less than theta S. Okay, so means the highest final temperature will be S. As you can see, smaller specific heat capacity will cause it to be heats up faster. Thus, increase in temperature will become faster. Okay, so answer is S. Number 13, diagram 7 shows the state of air molecules when sound wave from loudspeaker move through it. Topic wave, sound wave, longitudinal wave. So you can see there's a compression and rarefaction region as the heat sound energy transferred by air molecule, vibration of air molecule. What we want to determine, given this is speed, and then we want to determine frequency. Okay, the diagram 7, what we can get from here, this is compression, rarefaction, compression, rarefaction, compression, rarefaction, and so on. Okay, distance between two adjacent compression region is lambda. So means for 10 meter here, how many lambda we have here? 1, 2, 3, 4. Means 4 lambda equals to 10. Thus, lambda is 10 divided by 4, 2.5 meter. So we get the lambda. Now we want to find frequency. Formula V equals to F lambda. Thus we get frequency F equals to V divided by lambda. So 330 divided by 2.5. So we get the answer. Number 13. C, 132 Hertz. Okay, now look at number 14. Diagram 8 shows Kamal in a room able to hear the sound of piano in the living room. The situation is due to, so as the sound wave travel, it able to pass through the door here. Beside, we can see there's the wall act as an obstacle. So the door here acts as a gap or opening. So the sound wave propagate through the door by phenomenon of diffraction, diffraction of sound wave. I hope you understand the word diffraction. It's the spreading of wave when passed through a gap or around an obstacle. So we call it diffract. Penyebaran gelombang selepas melalui satu celah ataupun bukaan. Okay, so ini panggil diffraction. Number 15, diagram 9 shows water wave moving from deep region to shallow. So this is the deep region, this is shallow region. Distance between two wavefront is lambda. So this line we call it wavefront. Okay, wavefront and direction. The line with arrow here we call it direction of wave. So remember, wavefront and direction always 90 degrees. So this line that separate deep and shallow, we call it boundary line. Okay, So at the point of incident here, we draw a line 90 degrees to the boundary. We call it normal line. Okay, next, let's look at the question. Which of following will happen when wave entering the shallow region? Let's look at it. So angle of incidence is here, I. Travel from deep to shallow, what happened to speed? Okay, so when depth decrease, speed decrease, wavelength decrease. When speed decrease, what happens to the wave? It will bend towards normal. Smaller angle. Okay, so if you draw the line to show the patterns of the, you will get something like this. So this is the wavefront for shallow region. So you can see the lambda is shorter. Okay, so look at which one. Okay, the speed decrease, correct. Direction bends away, no, bends towards because the speed decrease. Wavelength decrease, correct. So answer is 1 and 3. Okay. Number 16, a monochromatic light wavelength given experiences interference after propagates through two slits. Bright and dark fringes form on the screen which are 1 meter from the double slits. The distance between two consecutive dark fringes is given. What is distance between the two slits? Okay, you must know all the symbol related to the value, wavelength, lambda. Bright and dark fringes form which are from the double slit. So this is D. Distance between two consecutive dark fringes is X. Distance between two slits. Okay. So the formula for interference, so we have this one. X equals to D lambda over A. Now we want to find A. A equals to D lambda over X. Now check the unit. Luckily all same unit. So you can just directly substitute. Okay, ganti terus. If the unit are different, you must change the unit first to the same unit. Okay, so you will get A equals to, okay, just to use calculator to calculate, you will get 5 times 10 to the power negative 4 meter. Answer C. Okay, number 17, diagram 10 shows paths of light. Refractive index of water and liquid P are 1.3 and 1.5 respectively. What is refracted angle R in liquid P? So we have water and liquid. So the Snell's law, N1 sine theta 1, N2 sine theta. So N1 is water. So we have 1.3 sine 40, N2 1.5 sine theta 2. Now we want to find theta 2, okay, which is R. So you will get sine R equals to 1.3 sine 40 divided by 1.5. So you will get is 0.5571. So R equals to, okay, 33.85 or 33.9. Okay, answer is C. Okay, so you must know this formula. If you use this formula, n equals to sine theta or sine I over sine r. This one is case for air to n medium, air and another medium. For example, air and water, air and glass, so we can use this formula. But if different medium than air, like liquid A and liquid B, so you must use n1 sine theta 1 equals to n2 sine theta 2 to get the answer. Okay. Okay, number 18. Diagram 11 shows optical tool by gemologists to evaluate gemstone. Okay, diamond. At which position the gemstone should be placed in front of optical tool to enable gemologists to see an upright and magnified image. Okay, so this one using lenses. Gemology is one of the application for uh, want to see upright and magnified. So you have, okay, for U less than F, U equals to F, U between F and 2F, U equals to 2F, U more than 2F, U at infinity. 1, 2, 3, 4, 5, 6. So I will just memorize something like this. Boom, boom. Rimris. Wait, wait. Okay. So the case to produce upright and magnified. So we just have these two distance only. Virtual, upright, magnified. So either U less than F or U equals to F. Okay. So from here we have, from the answer choices, we need to choose A. So U less than F, it will produce virtual, upright, magnified. Okay, the rest all real. Okay. Okay, number 19. An object is placed at distance 15 from convex lens, focal length 10 cm. What is image distance? This is object distance. This is focal length. You want to find B. The equation that relates these three physical quantity is length equation. So we can use straight away this formula. So this is convex. So the value of F is positive. 1 over 10, 1 over 15, plus 1 over 15. One over. Okay, so we get V equals to 30 cm. Answer D. This is reciprocal. Number 20, which of the following phenomenon experiences forces in equilibrium? Okay, if you look at this one, accelerate, of course, this is not equilibrium because there is a net force, so A is not the answer. A ship floating at rest, yes. A durian falling from a tree, no. This is acceleration. Okay, so answer is 1. Understand, the forces are balanced for equilibrium. Number 21, which of following diagram shows vector sum of forces 3 Newton and 4 Newton? Means resultant force or net force, vector sum. So for 4 Newton, and so you must check the starting point. Let's say this is starting point. So you have the first force 4 Newton followed by 3 Newton, and then from the same point there is 5 Newton. So 21, obviously answer is A. So you can see direction of the two forces, 4 Newton and 3 Newton, is just like following each other. Then this is the net force. The rest all direction wrong. Yeah? Number 22, three spring arrangement PQR, all spring use are identical. Identical means the spring constant are equal or constant. Okay. Question. Which comparison of the total extension of the spring when load 400 is hung? Which one extend more? Okay. Let's say if using one single spring, okay, extension is X. Okay. Okay. So let's say this is also 400 gram. So if two parallel, now the load is shared by the two spring, so it becomes half the force act on the spring, so the extension will become half X. Okay, and this one, these two part, 1 and 2, they are in series. So for the bottom part, it will experience 400 gram of mass, so this one will extend X. Above here, there are two springs, so it becomes half X. So this is extension for P is equals to half X. Extension of Q equals to half X plus X, which is 3 over 2X. Now we look at this one. One single spring X, below here 2 springs, so it becomes half X. Above here 4 springs, so it becomes 1 over 4X. So now for R is equals to 1 over 4X plus 1 over 2X. So it becomes 3 over 4. So from here you can see for X R, X Q. This is 1.5. This is 0.75x. This is 0.5x. So you can get the value. Okay. So you can see XQ is longer than XR, longer than XP. Q more than R, more than P. Answer A. Okay. Number 23. Given cross-sectional area of small piston and large piston are 20 and 80 respectively. So this is input, this is output. Okay, this is Pascal principle. Okay, according to Pascal, P1 F1 over A1 equals to F2 over A2. Small piston pushed by force of 40 Newton means F1. What is F2? So we just substitute into this formula. We want to find F2. F2 equals to A2 over A1 times 1. So A2 is 80 divided by 20 times 40. 4 times 40, so you get F2 equals to 160 Newton. Okay. Number 24. Diagram shows coconut 1.2 kg floating stationary on seawater, density of water given, G also given. What is upthrust acting on this object? Floating stationary means if you draw, let's say this is the coconut, okay? So there is a weight of coconut downward, mg, and of course there is a buoyant force X. And then this one are balanced because float stationary. So in this case, buoyant force equals to weight of the coconut. Okay, so the mass is 1.2, 9.81. We get the answer 11.772 Newton. Okay, no need to use information of density and all that. You cannot get by using FOG. OVG cannot, because we don't know what is the value of volume of water displaced. So we use this relationship. Okay. Number 25, Bernoulli's principle. Okay. Bernoulli's means when speed higher, pressure lower, and vice versa. Okay. If you let rocket, here is the momentum concept. The brake here is Pascal. This is Archimedes for the hot air balloon. So answer is D. The ping pong ball does not fall off because there is a difference in pressure above and below. Above, high speed of water will produce a smaller pressure. Water, larger pressure, okay, will cause the higher pressure to push the ping pong ball up. Okay, 26. Relationship between potential difference with current for different conductors J, K, L, M. From a graph of V against I, if you calculate the gradient, you will get V over I, which is equals to resistance. So means the gradient here shows the resistance of the conductor. So from here we can say G is steeper. Thus, Rj is more than Rk, more than Rl, more than Ra in terms of resistance. Okay. So the highest one, highest resistance will become G. The lowest is N. Number 27, diagram 16 shows rheostat X and Y connected in series in two batteries. V1, V2 are connected across rheostat X and Y respectively. Okay. So you have this one, this is rheostat and then Y. Which pair of voltmeter reading is correct when resistance of X is reduced? As we know that the value of voltage here directly proportional to resistance because they are in series connection. Okay, so this one, when resistance of Rx decrease, it will cause V1 to decrease. And then as we know, V1 plus V2, V1 plus V2 equals to total voltage. If V1 decrease, it will cause V2 to increase. Okay? V1 decrease, V2 increase. Answer is B. Okay. Number 28, which graph shows relationship between potential difference and current of ohmic conductor? So it obeys ohmic conductor means Ohm's law, B directly proportional to I. Number 29, a current carrying coil in magnetic field, which diagram shows pattern of magnetic field produced? Okay. Okay, current flow here. So if we draw north, south, so we have 2 points of wire, current in, and then here is current out. Okay, apply Fleming's left hand rule. You will get for current in, force downward, current out, force upwards. Means here is stronger, weaker, weaker, stronger. So the pattern will become like this. Answer in C. Okay, number 30. A ball magnet moves towards coil. Okay. What is the magnetic polarity of both ends of solenoid X and Y? So you can see north is spring towards Y. According to Lenz's law, Y will try to oppose the effect that produces current in the solenoid. To oppose the north pole, this one must become north pole or same pole. Then, if you know this one is north, meaning here is south, then apply right hand grip rule for solenoid. Okay, so you can see your thumb pointing to the right, because north is at the right side, and then the 4 fingers back to front. So you will have something like this. Okay. Okay, so this is the direction of current in the coil. So polarity X and Y, X will become south, Y is north. Okay, answer is B. Number 31, which of following is most suitable for transmission of electricity by national grid network? Type of current, alternating current, yes. Magnitude of current is low, voltage very high. So 31 is T. Because we use transformer, when we use transformer, only AC can be used, alternating current. Only can be step up and step down using transformer. So we cannot accept E. We need to accept G as answer. Okay, 32. Okay, number 32. Okay, diagram shows circuit consists of a diode and a bulb connected by dry cell. Okay, this is diode. When switch is on, the bulb does not light up. What needs to be done to light up the bulb? Okay, check here. Switch close. Okay, check the current flow. Current will flow from positive to negative. As you can see, this is diode. To produce diode forward bias, the P type must connect to positive. Okay, the N type must connect to negative. But now it becomes reverse bias, near reverse bias. So if reverse bias, current is not allowed to pass through. So what you do, you need to reverse the terminal of battery, or you need to reverse the position of the diode, either one. So we want to need, we can reverse connection of the diode. Okay. Number 33, diagram shows two bar magnets have been brought closer to the multi-cross tube and turned on. Which position the shadow or multi-cross be deflected? So for multi-cross, the charge that moves is electron. As we know, direction of electron and current always opposite. This case, you will apply Fleming's left-hand rule. Okay. Okay. So north to south, the electron is moving towards you, means out of the screen. So if electron is out from the screen, the current finger must place into the screen, opposite direction. So you can see your thumb is upwards. It's like this. This is the magnetic field for magnet. Okay, the current is into the screen. Thus, the force is upwards. So it means the multi-cross shadow will move upwards, direction of M. Okay. Here, so 34. Diagram shows incomplete circuit of fire alarm system. Table shows some suggested electronic components connection to enable the fire alarm to function. So what we should add here, there must be transistor as a switch. Okay. There must be a battery. Okay. And then there must be thermistor and one resistor must be placed here. Okay. Okay, so we have PQ thermistor, RS one resistor, TUB NPN transistor, and YZ battery. This one is correct. And then for 2 is wrong. It's wrong connection. Yeah? And then the third one is also correct. This one using NPN, this one PNP. Okay? So answer is 1 and 3. Okay, number 35. The following equation represent decay of polonium nucleus. What is presented by X? How to find X? Let's say X is AN here. AZ. Let's just put A Z. So A is equals to 210 minus 216. Yeah. Z equals to 84 minus 82. So 42x. This is equals to 42HE, which is alpha. Alpha. 36. What is the mass defect? E equals to mc squared. E is 2.6910 to the power of negative 12. And C is speed of light, 10 power 8. Can check the list of formula. Thus we get M. 2.99 10 to the power of negative 29 kilogram. Okay. Number 37, a nuclear reaction. So we have uranium bombarded by one neutron, split to two, barium and krypton. So the splitting of one larger nuclei to produce two nucleus, smaller nucleus, we call it fission. Nuclear fission. Number 38, which of following graph variation of d Broglie wavelength lambda is the speed of an electron? So d Broglie wavelength is equal to h over mv. Length constant divided by momentum. Okay. So the relationship between lambda and v is inversely proportional. So we get answer in a G. Yeah? Number 39, threshold frequency is the minimum frequency required, okay, for electrons to be emitted from the surface of metal. It's not photon that emits or escape, it's electron. So answer in 39. So we call it photoelectric effect. Okay. Number 40, work function of the metal is 3.1 eV. What is threshold frequency of incident radiation for an electron to escape from a metal surface? 1 eV equals to this value. So W equals to HFO. So you want to find FO. So FO equals to W divided by H. The work function you need to convert to joule. So 3.1 eV, you just multiply with this one. Okay. Then divide by Planck constant. Okay, so you will get the answer 7.48 10 power. Okay. Okay, so that's all the 40 question for paper 1 trial SPM 2021. This is a set from Kelantan. Okay, you can refer again the paper and try to answer the question first, then you can check the answer. Okay, thank you for joining my session today. Bye.